Well, good morning and welcome to our event today. I'm Todd Collart. I'm a member of this church, and the church is pleased to be a host for this event. It was organized by VCC, the Ventura Climate Coalition, and also the Citizens Climate Lobby. It's usually saying the acronym CCL and VCC. We'll get tripped up here. And instead of Unitarian Universalist Church of Ventura, we say UU Church. So excuse the acronyms. The church is one of Unitarian churches in general have principles that the church philosophy and organization revolve around. One of those is to respect and promote the interdependent web of life of all existence, which we are a part. And for that reason, we're particularly proud to be able to host this event here. A prior event like this was held at another UU church in Thousand Oaks. Obviously, with global warming and climate change, electrifying our lives is one way to address that and perhaps, minimize the damage to our lives in the future and the rest of the environment. VCC began in 2021. Its organization primarily focused on actions in the city of Ventura and surrounding area to deal with mitigating climate change and also adapt to it. And we were happy to partner with CCL, who had done this before, and we're they're linked to the west side of the county. So we've partnered very well, I think, and I'll introduce Adrian Conway with that group shortly. Part of my role here is to kind of familiarize yourself with the campus. You've probably been roaming around outside and all the chaos of booths going up. You probably volunteered to set up a canopy here or there and move some chairs. That's all part of the exhibition area. There'll be a few exhibitors in the adjoining hall. This is where all the lectures will take place. And for those of you who feel a little uncomfortable about COVID, we encourage you to sit over in your right side, where we have open windows, fans, and also air purifiers around. So if you feel free to wear a mask and sit over there, it might feel more comfortable for you. Bathrooms are located in a hallway just behind the sanctuary area here, and also Berg Hall is the large meeting room to your left outdoors. That's where lunch will be and refreshments during the day. There's two exhibitors there as well. And as you exit to the rear, there's bathrooms there. So they're available. You just have to find them. The parking lot areas, as you know, is very crowded. Hopefully they'll settle down as all the vehicles have arrived and booths have set up. We've tried to make sure that people coming in and out during the day are parked next door, so you can wander pretty freely without worries about being run over by something, but pay attention nevertheless. So it's busy out there. So while you're here, enjoy yourselves, be curious, ask questions. Volunteers will be wearing a volunteer button like this, and volunteers are supposed to know everything that's going on here except for the technical details. That's another button. If you see a button that says, ask me about solar panels, about heat pumps, about whatever else, those individuals have some direct experience with those kind of aspects of electrification. Also, the vendors are here to be questioned about their product line, their services, and they have a lot of technical expertise to share with you as well. We encourage you to stay hydrated. There's water fountains and plenty of water around, and we ordered up enough shade, but still warm enough. So it should be an enjoyable day for everybody. In terms of don'ts, we appreciate you, not smoking inside here or drinking in here. Bring a water flask. You need some water inside here, but do not. It's a sanctuary, so treat it like that. Now let me introduce Adrian Conway, who is going to talk about CCL, Citizens Climate Law. Adrian.
Good morning, everyone. Oh, thank you. And good morning to everyone joining us on Zoom as well. As Todd said, thank you for that introduction, Todd. I'm Adrian Conway. I'm one of the co-leads of Ventura County Citizens Climate Lobby. Myself and Faith Grant would like to welcome you. We'd also like to thank our host partner, UU, for the facilities for today's event and also providing valuable tech support. A big shout out to Brian. Thank you very much. That is allowing us to go ahead and have offsite viewing via Zoom and also to provide recordings of today's presentations. Links provided to watch the recordings, those will be up on our website after the event. We'd like to thank our sponsors, our partners, and our donors. Without your support, a free community event like this just is not possible. Also, I would be remiss if I did not mention our volunteer steering committee that has been behind the scenes, planning and designing this day. Every day, for the last 6 months. So a special shout out to Fran Lee, Richard Elsley, Terry Wallace, Joanne Cohen, Kathleen Wheeler, Wayne Morgan, Don Price, Todd Collart, and to our new social media intern, Irene. So if you would like to know more about CCL, VCC, or UU, we have booths that are right outside in the parking lot, right in the exhibitors section. Please feel free, step by. We'd love to chat with you about what it is that we're doing, not only locally, but statewide and at the federal level. The origin for this event was that we had been asking our volunteers. We have a chapter that's over 600 members strong in every city representing Ventura County. What matters to you? What do you think we should discuss? What do you think we should bring to the community? And basically what came back to us was we need information on the IRA, the Inflation Reduction Act. We need to know what's available to us. Where do we even start? Where do we begin? We understand that this is a huge piece of legislation with many different components, and the economic benefits as well as the health benefits of transitioning to clean energy solutions for your home or business, that could just be missed. We don't want that. We want everyone who's considering solar panels to understand the process. We want everyone who's thinking about buying an EV vehicle to know what rebates are available. And we want everyone who is wondering, what exactly is an induction cooktop? We want you guys to have that information at the top of mind and know where you can go for resources. So our goal today is that you get to not only hear about this information from our knowledgeable presenters, but that you have a chance to go and talk with our exhibitors and ask questions. We've got EV bikes here. We have a whole line of EV vehicles. The owners are really ready to talk to you about their cars and the specifics of them. Please visit with a representative from IEBW Local 952 and CFROG to find out about how they are setting up Ventura County young people for success by offering scholarships and training programs for green jobs. There's over 20 booths outside and then also in Berg Hall, across the way with exhibitors that are happy to share their knowledge and expertise with you. So with all that being said, it is my very dear pleasure to introduce a great friend of mine, Dr. Richard Elsley, who will act as our MC for today.
Is this on? It's on. Yes.
Could somebody advance the slide, please?
Second problem solved. I am a great enthusiast of electricity. I love electricity. My experience with electricity begins, I am told, before I was able to walk, when I would crawl around the house and stick things in electrical outlets. And my dad changed all the electrical outlets, so that was harder to do. And I watched him test it out, and then I crawled over and I used the new outlets also. So anyway, I love electricity. I will be introducing the speakers today. No, that used to show the list of speakers. But anyway, I will be introducing the speakers. I just put up a few things about why electric. And let's just run through these. Electricity is now cheaper than fossil fuels. You waste less energy. You know, when you're cooking with a flame, half the heat goes up to the ceiling. With electric, it doesn't. It's healthier. Kids who live near freeways have asthma way more frequently than kids who don't. It's safer. It pollutes less. Natural gas, turns out, has trace elements of things like benzene. That's why you should turn on the fan over your gas stove to get rid of that stuff. It makes good paying jobs, those guys who crawl up on your roof and put in the solar panels, things like that. And it's more resilient against natural disasters. There was a case, one of our members living in Baja California, hurricane came through, knocked out the grid, but people who had their own solar panels, they were up the next day. So anyway, electricity has all these advantages. And now the speakers have 30 minutes they can use all that to speak, or if they have some time left over, they'll ask you if you want to ask some questions. So you can do that either way. All right, our first speaker today is Judy Rachel from Home Energy Performance Pro to give you the general summary of what should you do to figure out what you want to do with your house. Judy.
Next slide, please.
Terrific, thank you. Guess I'm going to lower that for my little shorter stature. Good morning, welcome everybody. So happy to have you here. As Dick said, as Richard said, I'm going to talk to you about where do we start? Where do we begin? What do we do? How do we get this whole thing started? I was given quite a few discussion points, as you can see, that I get to cover in 30 minutes. So this will be a very high level overview and I won't be able to take questions during it, but I will be here all day. So you can seek me out if you do have any questions or discussions that you want to have with me. I welcome you to do that with me. So why are you here today? Why are you interested in electrifying your home or business? My bet is that there's almost as many reasons for wanting to electrify as there are people out here right now. But with a show of hands, how many people are looking to reduce their energy expenses? Okay, great, thanks. What about achieving some degree of energy independence? Okay, yeah, and some of these things overlap for people, right? What about reducing the health impacts of having those combustion appliances in your home? I'm seeing some enthusiasm with that one. And maybe anybody concerned about their carbon footprint? Okay, so yeah, there's so many reasons. What about mitigating some of the climate consequences of going electric? Okay, so whatever your reasons are, they're all valid, and that's what this event is for today. So how do we begin? Where do we begin? Electrification absolutely is a journey. So consider that it's a journey. It's going to take you some time. It does not have to be a long and windy road. But the end point of that journey should be energy efficient electrification. And I've had people turn to me and say, I don't have to be concerned about the energy efficiency portion. I'm going to have my own generation. Well, there's a number of reasons why that energy efficiency portion is not a feel thing. It's actually a technically good thing to do so that you can achieve better goals within your life and within your home and for quality of life reasons. So we all have a very limited space in which we can do that alternative generation. The alternative generation also only generates when we do electrical efficiency, when we have things that are energy efficient, we get these additional visitors to our lives that might have been unexpected, but I think are incredibly welcome. And basically what the 4 byproducts of going energy efficient are a more comfortable environment, a healthier environment, a safer environment, and a more durable home. So I think that in terms of quality of life, those are all very welcome additions. So at the risk of being Captain Obvious, how do you begin? Identify the gas and propane uses, the non-reusable energy sources in your lives, and then start looking for the electric alternatives. So on the one hand, it's truly that simple. Take it at your own pace. There's this wonderful guide that was created by Redwood Energy. They have it on their website at this URL. It is free for download. It's called A Pocket Guide to All Electric Retrofits. So whereas in the past, there were a number of things that we traditionally used in our homes that were non-renewable resource based, and now we have alternatives. We have really good alternatives, and that's what this pocket guide is going to help you find out about. There's also a kit from the Thousand Oaks Library that you can borrow. It's the Do-It-Yourself Home Energy Savings Kit, and it comes with some tools that you can use to help you identify the energy uses in your home, how much things are using. One of the most valuable tools in that kit is the kilowatt, and it's really easy to use. You just plug it into either an outlet itself or to an extension cord, and then you plug things into it, and it instantaneously tells you how much energy that thing that you've plugged into it is using. Now, if you're using something like, if you're wondering about, say, your refrigerator, which cycles over time, what the kilowatt does is you leave it plugged in over time, and it will actually show you how much time it's been plugged in and how much energy it's used over time, so that you can get a sense of those appliances that do have some flux to them. One of the most valuable things about the kilowatt is you can find those pieces of appliances that use energy even when you think they are turned off. And that's called vampire load or phantom load or just standby watts. So once you find those kind of things, you can make the choice to unplug them, to not use that energy when you're not using them, to put them on a power strip that you can just flip the power strip off. A second tool is a non-contact infrared thermometer. And what it does is it measures surface temperatures. It doesn't measure air temperature, it measures surface temperatures. I use this when I do performance testing in people's homes. I use it mostly for this heat stratification test, which is basically quantifying the performance of your heating system. It quantifies the performance in 3 ways. It reveals comfort levels, it reveals sizing issues, and it reveals heat loss across your ceiling assembly. So what I have done is that I have actually written up how I do this test, what the procedures are for setting up the house, how to actually do the test. And then I'm providing you also with the sheet that I use to put all the data down, do the little bit of math that needs to be done so that you could do this in your own home with this tool that you can get from the Thousand Oaks library. So all of this is on PDF in a Dropbox folder that you will have access to. So you'll be able to download these things. To set ourselves up for success, we need to realize that it's a whole process, and it starts with good design. And you need to take the time and do that planning and that design. And that is going to cost you some of your budget, but that is going to set you up for then your installation. And even though we assume that our installations are going to be done well, we actually do need to oversee our installations and make sure that they're actually done properly. And part of that is then the commissioning process. It's commissioning the systems that are installed and performance testing them to make sure that they're actually performing the way that we thought they were supposed to perform. So that should be the job of your contractors, and that's something that we should make sure that our contractors are doing. When we go through that whole process, we end up with lower energy use, which is going to allow us to put on less alternative generation and put on, have a smaller generator or a smaller battery backup, which will run our homes for either longer or be able to run more appliances on our homes when we do these things energy efficiently. We're going to get lower capacity heating and cooling systems. We're going to get greater comfort. We're going to get quieter environments in our homes. The very, very first step is what we call the test in. It's getting to know the building and figure out what's going on in that building, what needs to be done. The business model of a home performance contractor, so a contractor that calls themselves a home performance contractor, has this whole procedure as their business model. It starts with the test in, that energy audit. Once they've gone through your house and done the most thorough inspection that your house will probably ever have, they then generate a report with their findings and their recommendations, giving you a roadmap and the priorities of how to move your house along towards this path of being more energy efficient and electrifying. Once you've chosen your contractor, so even though the home performance contractor will do the test in and will give you that report, you still have the right to shop that report around to other contractors. Of course, the home performance contractor is hoping that you will choose to do the work with them, but it is your choice. But once you've chosen that contractor, that's when the planning and the design begins. Then, of course, we're going to execute and pay attention to those critical details. And then there needs to be that component of what we call the test out, which consists of both the performance testing and the commissioning of any systems. Here's a list of some of the performance tests that need to be done. These are done kind of throughout the whole process. They'll be done at test in to give us a base level reading of what's going on in the house and tell us what's going on in the house so that we can direct the roadmap. They are often used throughout the process to help make sure that the installation is going well, and then they're used for the commissioning and the test out. And so here's pictures of what those pieces of equipment look like and the various pieces of equipment that contractors should own in order to be able to perform these tests. Then there's this whole series, of combustion safety tests. If any combustion appliances are left on your home and you do any building enclosure improvements, these combustion safety tests need to be done. They are safety tests. The beauty of electrification is that All of those safety tests go away once we truly electrify and completely electrify our homes. This is a typical work scope if you actually are looking at doing building enclosure improvements and installing that new heating and cooling system. This is what a typical work scope is that you would probably end up getting for your building. The type of heating and cooling systems that have really kind of won and risen to what at this point are the most efficient and the most cost effective are the air source heat pumps. There's basically two types of air source heat pumps, and it's not new technology by any means. It's just that we have not, for the most part, been using it. There's the legacy equipment, which is unitary equipment. It's what we see. It looks very much like the air conditioners that we see outside of people's homes, and the air handlers are the same size as the furnaces that we typically have. The efficiencies, the HSPF is the heating efficiency, the SEER is the cooling efficiency. The efficiencies are good. They're definitely above building code, so that's great. And then there's this mini split technology. There are pros and cons to both, whether you're choosing the legacy or the mini split technology. The mini split technology can be both ducted as well as ductless. The legacy equipment is only ducted equipment. The mini split equipment also typically is literally physically smaller in size, which makes it easier to fit in our buildings, especially our existing buildings. The duct system, if you're doing a ducted system, is part of the entire heating and cooling system. You'll have a lot of contractors that offer to do what we call box swaps, where they're willing to leave the duct system that you already have in place and just put the heat pump systems hooked up to that old duct system. When we test old duct systems, we find that we lose about 50% of a system's capacity in this poorly constructed duct system that's not actually designed for the heating and cooling system that's attached to it. And so I've created just this 3 little scenarios of what the cost differences would be in terms of losing that 50% just through the distribution system when we've now put on this very efficient heating and cooling system, yet we get these losses. Then the second scenario is where many of our ducts are, which is an inhospitable environment up in attics. So when we still need to put our ducts in the attic, we need to keep the ducts tight, we need to keep them short, and we need to bury them in extra insulation. And then we don't have and design them with the heating and cooling capacity systems that we're hooking them up to. And then our losses get greatly reduced. We only get about maybe 15% loss. When we get the ducts into the conditioned space, that's where the magic really happens. Now we don't have duct losses. We still need to have the ducts designed for the capacity of the system. They still need to be tight, but getting them inside the envelope, now we don't have any of those losses, and you're actually getting the capacity of the system delivered to your house to offset your energy uses for that, for the comfort. There is a transition that's coming along that's important for all of you to know about, and it's about the refrigerant. With heat pumps, what's happening is that we're moving energy. We're not actually taking potential energy and creating kinetic energy. We're just moving energy. In moving energy, we need a refrigerant. The refrigerant is the magic fluid that moves that energy. The old refrigerant that we've been using since 2010 had a global warming potential of 2088. This new law is stating that as of January 1st, we cannot put in systems that have refrigerants with a global warming potential of more than 700. So in the next few months, these newer systems should start hitting the market. And so, depending on your mindset, you may want to, even before the January 1st deadline, be looking at a system that's using the newer refrigerants for all the reasons that we talked about earlier, as well as the fact that the R410A, the old refrigerant, is going to become more and more expensive as it becomes more and more rare to be put into the replacement systems. And also parts and components of the old R410A systems are going to be harder and harder to get. And we want a new heating and cooling system to last 20 to 25 years. Another thing that comes up with electrification is, can our electrical panels handle all of this new electrical load? Do we have to get a panel upgrade? And that is incredibly expensive to have to get new service wires and do a panel upgrade. So there's a concept out there called the Watt diet. And what that is looking at your panel and the appliances that you want to put on it and figuring out a way in which you can get all of those appliances into that panel. So once again, Redwood Energy comes to the rescue. They created a spreadsheet that you can download from their website that will help you kind of figure out what appliances you have, what you're using, and figure out, can I keep the panel with the things that I want to be using on it? And there are some amazing, great new devices out there that are these power sharing devices for some of our circuit breakers, where you can hook up your EV to the heat pump clothes dryer that you're using. And so both of those can share the same circuit, so you can't use those at the same time. So when you're drying your clothes during the day, you wouldn't be charging your electric car, you're charging your electric car overnight, and you wouldn't be drying clothes overnight. I'm just going to say it straight out. There is no silver bullet. Get it out of your heads that there is. There is no silver bullet, but there are 1,000 silver BBs. And what those are the critical details that we need to pay attention to in order to achieve our goals of electrifying, of doing it energy efficiency, of having that energy independence. When we pay attention to the proper details, all of this can happen. So with our homes, the most missed opportunity is air sealing our homes. And it's not about the doors and windows. The worst heat loss is across the ceiling assembly. And then the second worst is our floors, especially raised foundation. So this is a picture of a well-sealed top plates in an attic and a diagram of the various locations within an attic where air sealing needs to happen. In the crawl spaces, we need to get to the subfloor and the rim joists, and we need to get a ground source vapor barrier over that dirt soil so that we don't have moisture issues within our homes when we're tightening up our home enclosures. Insulation typically installed is 100% a waste of your money. This is a picture of a home that I was in not even a month ago. It was a very high-end home in Beverly Hills that was being retrofitted. This is typically installed insulation. And I don't know if you can see, but if you look closely, you can see that there's literally huge gaps where insulation is missing and the insulation is all compressed in the wood joints. None of that will work. The chart on the other side is showing you how quickly the effectiveness of insulation degrades with these kind of typical installation effects. With just 1% of gaps or spaces, we get a 50% reduction in the effectiveness of your insulation. So what do you do about that? You ask for a grade 1 installation. These are well-installed fiberglass bats. You need to actually tell insulation contractors to do their jobs correctly, to do them to the manufacturer's specifications of installation, and that's now called grade 1 installation. So we have a way of telling contractors, I want this done right, so I'm not wasting my money. This is spray applied cellulose. This is the most immune to installation defect type of insulation. It can only be done when the walls are open. There's also a spray applied fiberglass if you choose fiberglass instead. This is a loose fill product. It comes in fiberglass or cellulose. It gets blown in and it needs to be densely packed so that it doesn't settle. But it'll go around wires and plumbing and all that other kind of stuff that might be going through our wall studs. So it's also much less prone to installation defect. When it's done with open walls, it's done behind a net. This can also be done where we drill through the walls and we blow into each of the stud bays. The problem with that is it's very easy to miss stud bays. So you need to ask your insulation contractor, or are they going to look their work over with an infrared camera? That's the only way in an existing building with the walls up that we can actually see whether they did their job done right. So that's part of that commissioning test out that we should be asking our contractors if they do. This is a little home comparison case study. The home that was done that has the $15,000 conventional system was a hydronic heat pump by a home performance contractor, and the other home was just a standard contractor, HVAC contractor, doing business as usual. So the geothermal heat pump was basically installed because there were huge incentives. Both of these houses were built in 2005. And they didn't do any kind of load calculation, so they didn't actually know what capacity this house needed, but there were these huge incentives, so they just decided that more is better and installed 10 tons of capacity on this 6,000 square foot house. The home performance contractor did their load calculations, figured out that this 3,500 square foot house only needed 2 tons worth of capacity, and they designed their whole system. And you can see the differences of what these two contractors left as a legacy for these homeowners throughout the life of their equipment. The home performance contractor has a house that's using only $317 per year for heating and cooling, which at that prices then was 9 cents per square foot. Whereas the other contractor left their homeowners with 42 cents per square foot for heating and cooling their homes. They were only heating and cooling 600 square feet per ton of capacity, whereas the home performance contractor was conditioning 1,750 square feet per ton of capacity. I've written out this list of units of measurements. These are words that you're going to hear as you're going through this whole journey. It's also on PDF in that Dropbox. Vetting a contractor. Vetting a contractor, you should expect that they have design and performance metrics, which they should be willing to share, and that they should be willing to actually put into their work scopes. So I've written up a list of questions for you to have conversations and discussion points with contractors. There are specific ones for HVAC contractors, and I've also put out design metrics for you to show them and see if they'll promise those results to you and put those in their contracts for you. In terms of rebates, the best place to look is the switches on. You should also look at your local utilities, and there are federal credits, and I've given you websites, links to get to all of those, and this is also in the Dropbox. The contractors that are on the switches on website have only been vetted in the sense that they have valid contractors licenses and that they have the proper insurances. So don't assume that they will actually do energy efficiency work for you. I've also made some lists of terms for you to know. And then in conclusion, what I'd like to say is that there's many reasons for you to move towards energy efficient electrification, and your reason doesn't have to be the same as anyone else's. Making your building more energy efficient prior to adding that generation provides the opportunity to have a more comfortable, durable, and healthier building, potentially avoiding that electrical panel upgrade and reducing the need for alternative generation. There's many wonderful exhibitors here today. You know, get out there, explore, have fun, and thank you for joining us. Stay curious. Yes, we have some time for questions. I couldn't tell from this thing. It looked like I went over. So,
Question.
I'm here for questions. Yes.
Anybody have a question?
So we'll get a mic to you.
Simple question. Can you please just repeat the website where we can get all of this on PDF?
It's different websites. And so somebody through the organization putting it on should be providing the Dropbox link. So there's a Dropbox links, and all of those things are on different PDFs that you'll be able to view online and or download, which will give you those different URLs. Redwoodenergy.net is one of the main ones for the that retrofit guide, and also for the watt diet calculator. And then the switch is on, I think it's the switcheson.org, but all of that is on PDF for you.
Okay. Okay.
Oh, good.
Thank you.
I see a question over here.
Hi, thanks for that.
Yeah.
Do you think that the typical house from several decades ago should deal with its building envelope first? And I'm talking about windows and wall insulation before they start doing electrification?
I do believe that doing the envelope is really the key to being able to become more energy efficient, and making the entire envelope more efficient itself, that enclosure more efficient, gives you those other welcome guests, right? So that's what gives you all of those additional byproducts and benefits. And particularly, and actually I'm going to say it's not particularly our older buildings, but yes, our older buildings for sure. But even newer buildings have plenty of opportunity for improvement. We're still not paying attention to the right details during the construction process that our houses are really getting to where they could be.
How does all of this apply to condominium ownership?
To condominium, so at least with ownership, you know, you have choices that you can make, and even in townhouses, condominiums, and just HOA neighborhoods, you know, you do have to deal with some of the things with HOA, but a lot of this stuff is done from the inside, which you do, you know, have control over. Our renters definitely have more of a problem, but if you at least own the property, you know, you could look at your insulation. You can install a better system. I'm working with a townhouse owner right now who did have to argue with the HOA to get the outside unit moved to a different location, and eventually got approval. So now the entire complex is going to have that opportunity as well. There are some battles whenever we have any kind of HOA. Yeah.
Hi, I actually just replaced, or I added an air conditioner to my house and replaced my furnace less than 10 years ago, but before I knew about all of this. So I'm just wondering, what's the best strategy? I mean, I have solar panels, I have a battery, so I'm on my way, but would it make sense to just wait until it's time to replace them, or do you think there's a bigger benefit to going ahead and replacing them while they're still pretty new? Because I think they are more energy efficient than
What you had
older
prior.
units.
Yeah. Yeah. So that would be definitely something that should be looked at and explored to see kind of what efficiency there are at. Any furnace system is going to have losses. So one of the first things to find out is whether you have what's called our mid-efficiency, 80 efficiency furnace, which means that 20% of what is being generated ends up as waste heat. Or if you have a sealed combustion system, which then at least you're only losing 5 to 10% of capacity to waste heat. So we always have quite a bit of waste heat with any combustion appliance, no matter what. But you might want to look at enclosure improvements first. And since you've spent the money already on the heating and cooling system, and once you've kind of decided what you're doing with your enclosure, then go and have the load calculation done to see just how much that current system installed is oversized. And in all probability, it is quite oversized for your enclosure. So once you have the ability to have a more comfortable enclosure, then look to, all right, what capacity do I really need? And, where am I at kind of in my journey in terms of replacing? And that's something that an energy auditor would be able to talk to you about. And we had a question back here as well.
Okay.
I have a business in the Ventura River bed, which has a lot of, it's perfect. It's like paradise for temperature and summer and winter. Maybe about 30 days a year max when it's a little cold or a little warm. I brought there were two contractors I wanted to look at the heat pumps, and the two contractors, the only two recommended by 3C REN and CEC, way over, over proposed what I should do, like 3 heat pumps in the different spaces. And they didn't seem to take any account of the passive solar, and the passive heating and cooling that are part of the design of these 100-year-old buildings. So I might have missed it that earlier, but it seems like the main thing. And when I brought an engineer out, he said, just provide each workstation with a little space heater and a fan, and everybody will be very comfortable, and you save many thousands of dollars. You have any comment on that?
My only comment is that depending on how many workstations you have, those little electric heaters use about 1,500 watts minimum each, which is a lot of energy to heat, each individual person. That does add up. So even though the cost of those little heaters is way less, your energy cost is going to increase and would be more than if you did get some good systems in. You really need somebody who's going to do a load calculation on your buildings to see what the actual capacity is and where and how you're losing your heating and cooling energy from those buildings.
I have a question. The new refrigerant that you're going to have to switch to after the beginning of next year, will that make the system less efficient thermally?
No. No, it's the exact same technology. We're moving the energy, and it's the same exact refrigerant cycle that moves energy. So the systems won't become any less efficient. Yeah. They will just have less global warming potential, which I would like them to be even lower, but at this point we're still trying to invent those. Thank you.
Thank you very much, Judy. There was a lot of information there, wasn't there? I have done most of those things to my house, and typically my electric bill and my gas bill are both about $5 a month now. Well, actually, right now, Edison owes me $18 because of the cap and trade check that we get at the beginning of the summer. Oh, there's an honest company. All right. Our next talk is from Edison. Dave Intner is going to talk about those specific appliances and other things that you can then put in your house. Dave?
Thanks, Dick. We'll settle up in a bit. $18. Great. So thank you so much. Real pleasure to be here. Thanks for your presentation, Judy. A lot of great foundational information on how to set yourself up for success when electrifying and the considerations to go through. So I'm going to talk through a few things. So as Dick mentioned, a lot of the technologies that you're going to be looking at when considering electrifying your home or commercial space. Also, a lot of the common questions that come up that people have around electrification, and a high-level look at kind of the grid and the energy system and how that is going to enable and make electrification a true, effective and cost-effective climate solution. All right. So let's just start by looking at what the basic technologies are overall. And Judy did a great job of talking about the space conditioning equipment, heat pumps. And heat pumps really are the secret sauce for the most part. There's some other technologies we'll talk about here, like induction cooking, EVs, solar, batteries. But when you're talking about electrification in a home or office, a heat pump is going to address kind of the major building energy uses. Space conditioning, water conditioning, and to an extent clothes drying as well, because clothes dryers that electrify, you can get the kind of more standard resistance electric, but you can also get the hyper efficient heat pump type. So you can see here kind of the listing of all the different things you would see in a electric clean energy smart home. And the brains of the whole operation, of course, is the electric panel. And kind of setting that up right is important. There are some more advanced technologies, things like smart panels that kind of have a software brain that can help manage the different loads. And that can be a real great solution for integrating some of these technologies, but you can electrify just fine with a standard electric panel, whether that's 200 amps if you have the capacity or upgrading to that, or as we talked about earlier with the pocket guide, there's opportunities to do electrification, even if you still are keeping with the 100 amp panel. So they asked us also to mention some of the other uses in the home. So just a quick slide to talk about some of the lawn and garden equipment type of end uses. There's battery powered lawn equipment. There's a number of benefits to those, and there's plenty of options by dozens and dozens of manufacturers. First and foremost, the environmental impact, right? Not having to use those fossil fuels reduces carbon and contributes to cleaner air overall. Lower operating costs because there's reduced fuel and maintenance expenses. Fewer moving parts means less wear and tear. Noise reduction. This is incredibly beneficial in neighborhoods and business districts when you don't have those gas motors that are just kind of cranking and running. And you know, it's a lot easier on the operator too. So these folks that are using this equipment in landscape businesses and they have to have that hearing protection all the time, the electric equipment is much gentler on them. Very easy to use, lighter. You don't have to do the pull start, the pull cord. How many times have you like flooded the engine and you just yanking on that thing and you know, it just won't start, right? So having that push button, battery powered, super easy. And then finally, very convenient. No need to go to the gas station and fill a gas can, risking spills and other kind of nasty things. You just go ahead and charge your battery and you're good to go. So the question comes up, like the conventional wisdom has always been, well, isn't it more efficient and better to just burn a gas appliance in your home than to burn gas at some remote power plant, have that efficiency loss, those conversion losses, the transmission losses, and then you go and you're running some sort of an electric end use at your home. So there's two reasons that that's no longer really the conventional wisdom. So the first thing is the state's tremendous progress towards a clean energy grid overall. We're close to 60% carbon neutral energy. That's both renewables, large hydro, and nuclear, which we still have some of on the grid. You know, prior to about 2010, yeah, I mean, predominantly we were mostly a fossil fuel grid, some hydro, some nuclear, but the vast majority was fossil fuel. That's diminished significantly as solar has become increasingly cost competitive. You know, wind is right there in the mix as well. Continuing to have hydro be a major contributor as well. And now batteries, as we'll talk about a little bit later in this presentation, really helping a great deal to further extend the availability of that renewable energy into the shoulder hours of the day and into that really critical evening peak. And the state has a goal of achieving 100% clean electricity by 2045, and we predict we'll get to about 80% by 2030. So each year, you know, maybe 2 to 3% increase in the penetration of renewables. And of course, you know, the Clean Power Alliance is out there, and if you're in the Clean Power Alliance territory, you can opt in to the 100% green rate today, right? As a voluntary thing. So this chart is a lot. I know it's like it's a bit of an eye chart, but let me just explain. It's an important concept. I'm going to break it down for you. It's what's called a Sankey diagram. The Department of Energy puts these out every year. The left-hand side is where all of our energy comes from. So this is the entire U.S. energy economy in one snapshot. The left-hand side is the sources of energy, the supply of energy. In the middle is where all that energy flows through. So we have the electric generation. Much of that goes to residential, commercial, and industrial end uses. We have the transportation piece, largely served obviously by petroleum because of internal combustion vehicles, but increasingly we're seeing more of that electric generation come in there, and the goal is to bring a significant portion of that. We're already at roughly 25% of new car sales in California are EV as of, you know, the beginning of this year. So we're seeing that market penetration in the state really starting to take hold. But of course, we have all these existing cars, so it's still not as big a percentage. Now, the key thing I want to point out is that in a fossil fuel based energy economy, which, you know, the bottom three of the bottom four boxes are fossil fuel, but additional one's combustion there. The two boxes here on the end, the light gray and the dark gray. So that light gray box is how much energy we waste in the form of heat in getting the stuff done we need to, you know, manufacture our stuff, to move our cars around, to heat and cool our homes, all of that. The dark gray box is the useful work, the useful stuff that we burn energy with, that we expend energy to do. So by electrifying, we are doing two things. We're becoming very efficient, so we're reducing that gray box by efficiency. We're also reducing the amount of useful work, because heat pumps and induction and other electric vehicles, all of these technologies are radically more efficient than their traditional counterparts. So electrification helps us shrink both boxes. And of course, when we go to renewable sources of electricity, it further shrinks that gray box. And of course, all the carbon that's associated with the burning of those fossil fuels goes down as well. So how do we shrink those boxes? These technologies we're talking about, heat pumps, induction cooking, electric vehicles, extremely efficient relative to what we're traditionally used to in our homes. Heat pumps, basically, as Judy explained, use that refrigerant loop to move heat from one place to another. Because you're not converting a fuel from one form of energy, a chemical energy, into another form of energy, heat, you are just using that refrigerant loop like a sponge, using a compressor that makes that refrigerant hot, and then an evaporator that makes it expand and cool down. Depending on where you are doing the heating and cooling part, you're moving heat from one place to another. So when it gets really cold, it absorbs heat. You move it through that loop, and then you run a fan over it. It rejects the heat. So either you're rejecting the heat inside when you're in heating mode, or you're rejecting the heat outside when you're in cooling mode, right? So you think of that refrigerant as a sponge that contracts and releases to move that heat from one place to another. That takes, on average, 1 unit of energy to get 3 units of useful work, useful conditioning heat energy, if that makes sense. So that's really the magic there. That same technology applies to water heaters. So heat pump water heaters allow you to use that refrigerant loop heat pump process to heat water. So it's rejecting the heat into that body of water, that tank of water, and then providing a little bit of cooling into whatever space you have it in. So that could be your pantry, it could be your garage, wherever. So there's a little side benefit to that as well. Gas furnaces and electric resistance top out at, 90% efficiency range. And that's when you have the kind of higher efficiency condensing models. The standard ones are in that 80% range that Judy mentioned earlier. What about cooking? So gas stoves are roughly 40% efficient. Most of the heat energy goes around the pan and up into the space around you. So that's why they recommend, go outside and grill when it's hot, so you're not adding heat to your kitchen. You just kind of have to remove with your air conditioning, right? Electric resistance, so the kind of the glow coil type of, the old, awful, electric stoves that maybe you knew growing up. In some cases, those are about 74% efficient. So still a lot more efficient, but not very responsive. Those coils would stay hot for a long time. The kind of ceramic cooktops that have the all glass and are still electric resistance perform a little bit better in terms of that overall cooking experience, but still, in that 70+% efficiency range. Induction, however, they use a whole different process than electric resistance. They create a magnetic field that directly excites the molecules in the pan, so the pan itself becomes the cooking vessel, the cooking element, and it puts the heat directly into the food. So they are around 90% efficient. And if you go out to the SCE booth outside, there's a small induction cook plate that'll show you kind of how quickly It boils water. It's amazing. And it's being operated right now off of Kent Bullard's Cybertruck. So thanks, Kent, for for driving that up and letting us use that as an example. So this will kind of build a little bit on what Judy talked about earlier, but what considerations come into play when electrifying my home or business, and what resources are there to support? So there are a number of factors that are going to affect the cost when you're considering retrofitting. New construction's a bit more straightforward because you can plan it all in, you can avoid the gas infrastructure altogether. So there's a huge cost savings in new construction when electrifying because you're eliminating the cost of an entire utility that you don't need. So retrofit gets a little bit more complicated because everyone's circumstances are a bit more unique. So one question is the available space for the equipment. If you have a really tight water heater closet and that heat pump water heater, maybe it's a little bigger. It's got it's higher because it's got the compressor on top. It's got the insulated tank that may be a little bit larger than your existing unit. So is it going to fit? Do you have to make modifications that could affect things? Existing panel capacity, that's going to be a factor. How far is your electric panel to your appliance locations? Is it just really close by, or are you going to have to run a whole bunch of long conduits to your different end uses, which will add cost? Contractor availability will affect the kinds of bids you see and how familiar those contractors are. Are you paying for their learning curve? Do they perceive risk because they're not as familiar? The timing is important. If you plan ahead and you say that you're doing one electrification project and you go ahead and install some of the infrastructure so you're ready when you're going to be changing out the next device, that can really help. If your water heater fails and you don't have an outlet nearby that you can plug that water heater into to change to electric, you're going to need to, in a emergency situation where you have no hot water, try to find a plumber and an electrician and time all of those things and deal with the permits and all that. So that can really complicate and frustrate your experience there. What equipment you select and what the features are, there's a whole range. Can be, modest or can be expensive depending on those considerations. And then the question I think came up earlier, the remaining useful life of the replaced equipment. If it's already at end of life, you're just looking at the delta of what you would be changing out versus what the electrification alternate is. Or are you doing an early replacement and then the cost, maybe there's the sunk cost is there and, there's not as much motivation potentially. So just a couple additional points on the pocket guide that was brought up earlier. It is a great resource. Considering things like load sharing devices that allow you to set a priority. So if you are cooking, let's say you have your stove and your electric vehicle charger sharing an outlet so that you're maximizing the capacity in your panel, you can set the priority. When you're cooking, it'll pause the charger if they're operating at the same time. And then once you're done cooking, it'll just resume charging. So those are kinds of things you can do to maximize the available space in your panel. 120 volt heat pump water heaters are available, so you don't necessarily need to do the upgraded outlet. You can use a shared circuit or a dedicated 120 volt circuit, depending on the unit. They're also now on the market. It just came out, 120 volt induction stove that has an onboard battery that charges, that gives you the boost that you need if you need to draw more power than would ordinarily come from the 120 volt outlet. So a lot of solutions are being directed at the retrofit market. So that's real important. And then, of course, the real magic part of Judy's talk was improving envelope efficiency will help you reduce that HVAC size, and maybe that allows you to downsize what would ordinarily be recommended for your compressor. That could save some panel capacity as well because you're right-sizing your equipment for the actual load that home is going to see. So yes, absolutely check out the pocket guide and the watt diet calculator. And then a number of the important rebates and tax credits. The Inflation Reduction Act is a great resource with a lot of different technologies that it supports. it's going to be available basically for the next 10 years. The tax credit portions are annually renewable. So if you do some envelope upgrades this year, maybe you put in new windows this year and then you do air sealing the next year, you still get that same base tax credit that you can apply year over year as you phase your projects. $2,000 for heat pumps, $2,000 for heat pump water heaters, $4,000 towards PV panels. So a lot of really great resources there, and I'll give you a great link to kind of look at your specific what you might qualify for based on your income levels, how you can calculate that. There's a great resource for that. Additionally, there's the Tech Clean California program that supports both HVAC and water heater heat pump installations. That's available through the best portal, again, is the Switch is On. And they'll be getting a new round of funding this fall sometime. I don't know the exact date, but keep an eye out for that, because those are very good incentives, and they can also help support the electrical infrastructure needed to support a 240-volt installation as well. So that's the Switch is On webpage. Again, help you find contractors, help you find the different rebates for the technologies you're looking at, and just general information about electrification that helps to support that. So switcheson.org. And then Rewiring America has a terrific calculator where you can enter your address, income level, home square footage, et cetera, and it will kind of break down by topic area what types of technologies you may qualify for. And then, yeah, there's going to be some rebate programs coming through the state associated with the IRA. The date hasn't been set yet. They're going to be administered through the California Energy Commission, but that should be coming toward the end of this year, beginning of next. And Rewiring America has some info on that as well. Okay, so question sometimes comes up too about resiliency. And isn't it better to have multiple fuels serving my house in case there is a power outage? And certainly areas like Ventura and other areas close to the wildland urban interface have some recent history with outages related to the impacts of climate change. Edison as a company and all the utilities in California have really worked tremendously hard in the last 5 and 6 years to address the grid vulnerabilities and invested billions of dollars in what we call grid hardening. So this is putting in things like fire-resistant poles, covered conductor that won't allow an ignition if a branch falls across, so that that branch vegetation doesn't make contact with the actual conductor itself. High resolution HD weather stations and cameras, fast acting fuses, a whole number of things to reduce the potential for outage, as well as the potential for a proactive outage to when we have those extreme heat and wind conditions that could lead to an ignition, changing those thresholds so that the grid will withstand those things and not have to be proactively shut off. On average, we maintain these statistics and report them to the CPUC. The average SCE customer experiences 1 outage a year for a duration of about 2 hours, which, when outages happen, they're certainly inconvenient. They can be very disruptive, but we do aim to make them as infrequent as possible. You can never completely eliminate outages because they're necessary for maintaining and upgrading the grid in many cases. You can't change a pole out or change the wires without isolating and cutting off power to those areas. But we make a lot of efforts to isolate the outage area to minimize that disruption. And it's important to note that modern gas appliances don't typically work if the power is out. Nearly all modern gas appliances have electronic ignition or controls that are necessary. There's an image of a tankless water heater. That's the electronic control panel. It also has a power exhaust, which it won't operate if the power is not on. Same thing for a forced air system. You might have a gas furnace, but you can't distribute any air through your ducts if that fan isn't working, right? Additionally, there was talk at the outset about the pollutants from combustion indoors, and the code requires proper ventilation for use with stoves. So in the same way that you wouldn't roll in a propane grill into your kitchen and start cooking on it, you really shouldn't be cooking indoors without that ventilation. Number of studies have shown the level of pollutants is much higher than conventionally thought from the results of combustion, and the impacts on things like childhood asthma from the presence of and use of a gas stove in a home have led to recommendations from the American Medical Association, Lung Association, and others to consider alternatives to these sources of cooking in your house. And then finally, for vehicle fueling, and I know that Don Price is going to do a really great deep dive on vehicles, but gas pumps require electricity to function as well. So if there's an outage affecting your area, same way you'd need to drive somewhere else to gas up, you can drive somewhere else that has power to charge. And PV and battery, the codes for new construction are increasingly requiring these. PV is required on new construction, and battery readiness is required. So you have to segregate a critical loads panel in new construction that would accommodate a future battery. Non-residential and large multifamily, so 4 stories and above, actually require prescriptively PV and battery. So more and more the codes are requiring that. And if you have that PV and battery system, you can, and it's properly sized, that can meet your basic needs potentially indefinitely if you do experience a protracted outage. Sorry, PV means photovoltaic panels, yes. So then the question sometimes comes up, like, aren't these heat pumps newfangled, strange, space age technology, and is it really vetted? Is it really something that well, I don't want to be a guinea pig. Well, the truth is, heat pumps are everywhere. The heat pump was invented in 1856. You have had a heat pump in your house your entire life because your refrigerator is a one-way heat pump. It uses that refrigerant as a sponge, absorbs heat from that box that keeps your food cold, and rejects that heat out into your kitchen. If you reach down under that grill, you can feel when it's operating that there's warm air coming out. That's the heat from your beer and your eggs and your milk being put into your kitchen to keep those things fresh. Really, the difference between a traditional air conditioner and a heat pump is 2 components. There is a reversing valve and a defrost controller. So when you're in heating mode, if the humidity is right and the outdoor temperature is cold enough, you might get some frost on that outdoor coil. So there needs to be a means of controlling that, and whether that's a resistance element or they'll run that heat pump, reverse it, and blow hot air over it. Basically, we get the hot refrigerant going through to get rid of that frost. But basically, that's the difference. Otherwise, it's almost the same thing as the air conditioner that you have currently. It just works in both directions. So you get 2 end uses out of the same appliance, which is great. Additionally, heat pump market share is rapidly increasing. So they're very prevalent in Asia and Europe, have been for decades, more common in the southeastern US. But in 2022 was the first time that heat pump sales actually exceeded gas furnace sales. And they're required now prescriptively in Title 24, depending on the climate zone you're in. You might have a heat pump space conditioner or water heater as your prescriptive. So doesn't gas provide an overall superior cooking experience when you compare it to electric? Well, this is my old gas stove before I got a induction stove recently, and I gotta say, this was not a fun experience. We did like some fried chicken cutlets the other day on our induction cooktop, and cleanup was like a minute and a half. On my old stove, the same thing with the grease spatter. It would have been like 12 components I would need to pull out: the grill, the little burner covers, all that, and would have taken 20, 30 minutes. Just awful. So greater precision and control, enhanced safety, ease of cleaning, better overall air quality, and water boils twice as fast. It's amazing. The old thing, a watch pot never boils. On induction, you'll just see it in real time. It's so cool. And the adjacent surface remains cool to the touch while cooking. So very safe if you have children, pets, elderly, etc. And they perform very well. Consumer Reports, their 2020 rankings, 6 of the 8 top-rated stoves were electric, with the top 2 being induction. And we're cost competitive with those high-end gas stoves that performed well in those rankings as well. So the last point I want to make is the question about, well, how's this going to impact the grid? Can the grid handle the new load coming in? So the grid impact of all electric homes is actually relatively minimal because we designed the grid infrastructure to handle peak demand. And yes, electric homes will use more electricity, but that electricity is spread out more over the course of the year. This is a look at peak load on a transformer in 2 different neighborhoods. One was a mixed fuel and one was a comparable all-electric neighborhood with solar photovoltaic. You can see that and this is a annual 12-month look, and you can see there's a much more steady kind of demand peak with the all-electric that's comparable or a little bit less to what the summer, where that air conditioning is really driving the peaks. And the peaks are very similar because that air conditioning load is very dominant between the mixed fuel and the all-electric. So the infrastructure doesn't change a huge amount at the grid level. And then batteries on the grid are becoming a very important piece. We touched on this earlier, and I think the next presentation is going to talk about deploying batteries at the home level and solar. But the light green area is where batteries are starting to really bring that abundant solar that's available during the day and bring that into the evening and significantly reduce the need for fossil fuels later into the day, even when the sun's not shining. The first time, April 16th of this year, we had the batteries actually be the predominant source of production on the grid for the first time ever. So they were producing more electricity to supply the grid than natural gas. So that was a first. So even though the sun was down, solar energy was the predominant source of energy on the grid. So we're doing a lot of advanced forecasting to ensure that the grid is ready, looking at areas where, like transit corridors, where we know there's going to be a lot of fleet electrification to make sure the grid is ready for these things when they come, and understanding what neighborhoods have the most capacity and targeting those neighborhoods that are most constrained. So there's a cyclical forecast that we're doing that's being proactive to ensure that the grid's going to be ready to accommodate that. Just going to leave you with a couple of links. So SCE.com has workshops that do deeper dives into this topic. Energy Code ACE helps with the code elements of this. And then 3C REN is a great local organization for connecting to resources, contractors, et cetera, as well as the slides I provided earlier that you'll have in the PDF for Switches On and Rewiring America. So thank you for your attention, and yeah. I think we have time for a question or two.
Hi, this is actually for the organizers. I'm looking at my program and the resources are showing the names of the resources, but not the actual website. So I'm wondering, where can we find that? They're links, but when they're printed, it doesn't help.
They go to ECL website.
Okay. All right, sorry.
So the organizers suggest going to the CCL website to get the link for the Dropbox and all the presentations. There's a question over here too.
Yeah, just go to the CCL website. So Citizens Climate Lobby.org, I believe. And we'll have the videos of the talks. We'll have all the resources with the links so that you won't have to search around for them. And then there'll also be copies of the slides provided, so you can go over everything.
You know how you are talking about battery storage at the house? So like with most battery, it tends to, over time, it tends to not be as efficient and stuff like that. So these battery panels that you're putting into your home, how long do they normally last?
Yeah, so that's going to be a great question for the next presenter who's actually from Simpliphi, is going to be talking about batteries. That high level, what I would say is that these systems are usually designed for like thousands of charge cycles.
Mhm.
And even when they reach a point, and that's to get to like 70 to 80% capacity. So the degradation isn't like they're useless. It's just that they lose some of their efficacy. You see that in EV batteries. So EV batteries are considered to be like the end of their useful life when they're down to like 70 or 80%, and that affects their range. But then they take those batteries and they can use them in these arrays where they can use them as backup for the grid. So they put them in these containers, hook them all together, and they get another life once they're done in the vehicle. So I would say the next presenters will speak to that in more detail, but you know, they're designed to have a lot of charge and discharge cycles.
Just hold it right up to you.
How smart is the grid currently?
How smart is the grid currently? So more and more every year, there's day ahead forecasts, right? With the independent system operators, that they have algorithms that can predict what supply and demand are going to be and what type of resources are needed. And that's a pretty reliable system. There's going to be more technology that interacts with these different appliances, because there's huge opportunity for demand response signals. When we have some programs now that will, you know, like your smart thermostat program, there's a utility signal that says, hey, we need people to reduce usage, and it automatically will tell your thermostat, if you're enrolled in that program, you know, change the set point by 4 degrees. You hardly notice it, but you get thousands of people doing that, and it actually has a pretty big impact for the grid. The same thing is coming into effect for water heaters. So telling water heaters, electric water heaters, heat pump water heaters, just avoid charging or heating the water during these like 4 to 9 p.m. periods. So those types of controls are getting, there's already that for lighting, for thermostats, and more as we electrify is going to have the opportunity to do that. Battery systems have that capability. So it's just a matter of getting more programs in place and more customers signed up to do that. Question in the back.
I'm just curious about what's Edison's take on bidirectional charging from EVs and how it might affect frequency response and that kind of stuff.
Bidirectional charging from EVs?
Yeah.
Yeah. So we have a pilot that's looking at the potential and the technologies and the controls and the types of things you're talking about, where there would be different, very technical, like modulation and voltage and all that kind of thing. I'm not an engineer myself, so I couldn't speak to those elements of it, but I can say that leveraging those types of distributed energy resources to provide that grid stability. I talked about briefly like the potential for just the grid side batteries to help to extend the value of that daytime solar into evening hours. There's almost twice as much battery capacity sitting in people's driveways than we have on grid side storage. So it's going to be a huge piece of the puzzle, how we tap into that resource, how we make that work, kind of effectively. But we basically, at the end of the day, there's not a lot of difference between a stationary battery that we're already interacting with that's attached to your house, right? And that EV battery. The simplest thing would just be using the stationary battery or EV battery as a demand reduction. So drawing off of your battery instead of the grid during those peak time periods, it helps to reduce strain on the grid. And it also helps to save you money because you're taking energy you've stored when energy is cheaper on a time of use rate. And then you're drawing that from that and avoiding pulling from the grid when power is most expensive. Yeah. Great. Thank you so much.
Thank you, Dave. Very informative. When I put in my heat pump furnace and air conditioner, afterwards I thought, well, what next? Do I want to rush out and replace the hot water heater? Well, I wasn't in a big hurry to spend more money. 2 days later, I went out into the garage and there was water spraying all around the garage because that pipe at the top of the water heater, which is the one that always corrodes most, had gone. And I looked around and I smiled and I said, I get a heat pump water heater now. And it has worked out great. Okay, the final session of the morning is going to be 2 presenters sharing the time. Solar panels and battery storage. And first is Mary Elizabeth Glosup.
I'm just going to switch it. If I can go from here. Great. Hello, everybody. I'm just going to tell you a little bit about United Solar. We've been in business for 13 years selling and installing solar on both commercial and residential real estate. And our sister company is United Electric, which has been in the electrical business for 44 years. Just basically a little bit on how solar works. I see I'm a little bit behind here. Which one is up there? Okay, let me go back. No, we're missing. Okay, good, that's what I want. So basically, solar panels convert sunlight directly into electricity. Groups of solar panels are called a solar array. And the more panels in an array, the more power they generate. The inverter transforms the DC into AC electricity, a process that makes the energy that is suitable for use by our household appliances. When your solar system is producing more energy than you are consuming, that excess energy is sent to the utility unless you have a battery. The electricity generated by your solar system is the exact same energy that you get from the utilities. And at night, your meter draws from the utility unless you have a battery. And this is just a diagram of what that looks like. I don't know how clearly you can see that. How an inverter works. Solar inverters are part of your solar power system that converts the direct current from your solar panels into alternating current that your home uses. While the inverter is a less visible part of your solar power system, it is a very important part of the solar system. Then we get into the placement of the solar panels. So the best type of roof for solar panels is a south-facing roof, as they tend to generate the most electricity from solar panels. South-facing roof panels see the sun when it is at its most intense during the day for the longest period, which is why they generate the most energy. East and west-facing roofs are also suitable for solar and will see a good deal of energy generation throughout the course of the day. East will get it in the morning, west will get it in the afternoon. So this is just a compass so you can see north, south, east, and west, how you would place panels. And then the next thing is, have you seen advertisements for free solar? That you can get your battery for free. Here's one of these advertisements. I'm not going to read so much of this. Will the government pay for it? I don't want to be the bearer of bad news, but there is no free solar. And it is really a sales gimmick. But there are 3 ways to buy solar. The first, of course, is cash or finance. then you can have, there's a solar lease or there's a power purchase agreement. And it's best to deal with a company that offers all three so that you're offered what really is going to be the benefit to you. If you can't use the solar tax credit, you may want to do a lease or a power purchase agreement. So if a leasing company just comes out to you and that's all they're offering you and you can use the solar tax credit, you've lost that. So cash or finance, it's very simple. You do a cash deal, you're going to have to do $1,000 down payment, and then there's 2 payments along the way, and really not until the installation starts. With finance, it's best to have a 650 credit score, and you just go through the normal channels of financing. And our company uses a credit union where there's no points or fees. There tends to be a lot of points and fees in solar financing. And we don't, with our credit union that we use, there's no points or fees. And when you pay cash or you finance, that's when you're eligible for the tax credit. So with a $40,000 solar system, you've got a $12,000 tax credit available to you. What is a solar lease? What is a power purchase agreement? So with either of those, you're renting the equipment. And so with a solar lease, you have a fixed payment that you have every single month. And with a power purchase agreement, you are agreeing to pay for the power that's been generated off the system. No matter what month it is, whatever it generates, you're going to pay that. That's what you've agreed to. In both of these cases, you do not get the solar tax credit. The company that has installed this for you, and it's a finance company, they get the solar tax credit, but that portion of the tax credit is discounted for the system. You'll see that the system costs a little bit less. The other thing that people like about both of those is that you're not responsible for the system maintenance or monitoring, and additionally, you get a performance guarantee. So say Southern California, for 6 months out of the year, we had rain, and you were offered whatever amount of energy you were going to get, you will get a check back from those companies. So it depends upon which is the right system for you. So what is the solar tax credit? It's very important to know this. I have a friend who just got solar and he goes, "Oh, I'm going to get my rebate." And I'm like, there's no rebate. It's a federal tax credit. It's against taxes owed. So let's see, what do I say here? Yeah, claimed in taxes. Okay. So the IRS has kept $30,000 of your money. You've done everything you could to write it off. You get a $40,000 solar system. You've got a $12,000 tax credit. Of the $30,000 they kept, you're going to get $12,000 back. If you're a business owner or 1099 and you've got to pay taxes in, with a solar tax credit, you pay that less. That's what the difference is between that and the rebate. Okay, net metering. And Sequoia is going to go over net metering more and also on batteries. But basically, net metering is a system that allows homeowners with solar panels to sell their excess energy they generate back to the grid. This means when your solar panels produce more electricity than you use, the surplus gets sent to the utility company and you receive credits on your electric bill. This helps you save money by reducing your overall energy costs and makes your investment in solar even more valuable. So does everybody know now we're in for SCE, Net Energy Metering 3.0? Okay, good. So basically this shows you, how net energy metering works. So your solar panels convert the energy from the sun. The inverter changes the direct current into alternating current. Then the energy is used in your home, and what you don't use gets thrown to the grid. And then at night you pull it back unless you're throwing it to your battery. Now, batteries. Do I need a battery? Are you required to have a battery in NEM 3.0? You are not required to have a battery. You do not have to get a battery. But what we're finding is the return on investment is much, much better with a battery. And you can also be have it so if there's a power outage, you have your energy at night, your electricity at night. Without a battery, we're seeing return on investments 10, 11, 12, 13 years. With batteries, 6 to 9 years. So solar size evaluation. It's so important to get this right. So what we want to size a solar system for you is we want the last 12 months of your energy bills, because that gives us a historical usage of what you've used. And then we want to know how old is your roof? It's very important that the roof can sustain a solar system. What is your roof made of? What future changes are you making? Are more people moving in the house? Are people leaving the house? Are you getting an electric vehicle? Are you going to go all electric? I have somebody right now that, he was like, I don't know if I want to do solar. He's building a pool. He's getting an electric pool heater. He's now doing solar because of the electric pool heater. So we want to know all of that so that we can get the right size system for you. Some people do not care about their SCE bill. They want to go green. That's all they care about. Where other people, we want to know, why do you want solar? Do you want to get rid of your SCE bill? What is driving you so that we can get the right size system for you? Because you only want to buy solar once. That's most important. And then the next steps, you've all decided to buy solar from me. Thank you so much. I have a booth right outside. So what happens when you've decided you want to go with solar? We need to know, again, what's going on with your roof, and we need to know, can your electric panel handle this, or do you need to get an upgraded panel? And if you do get an upgraded panel, you do get the 30% tax credit on that as well. So we've done all that, and my guys come out and they are now going to look and see, did I do a good job? Your roof is fine. What's going on with your electric panel? Measurements are done, and then they go back and we do design and plans. Once the design and plans are done, then it goes to permitting. And depending upon where you live, permits can be 4 to 8 weeks. I live in Santa Clarita. I have 2 deals going right now, and it's been a lot longer than that. It just depends upon what's going on, but we get the permits. We get the okay, we've got the permits in our hands. The next day we have the equipment delivered, and installation can start that day or the next day. And it's usually 1 to 3 days, usually 1 to 2. We just did a deal in Camarillo and they had 3 batteries. That was a 3-day installation. And then we call for inspection, and the inspector comes out, everything is all good to go. And then we apply for PTO, which is permission to operate. So that's the paperwork we do on our end that we send to SCE, and then they will turn on your solar system and get it going. And I think, what to consider when getting solar. So really you want to think about, do you want to get a battery? And that's something we go over and talk about. What is your intention? Are you looking to get rid of SCE, like I said, or you just don't care? Which most people want to get rid of the SCE bill. That's what I have found. The tax credit is remaining till 2032. And you just have to look over what the plans are for California, which you guys have heard a lot about that today. We are going electric. A lot of people are getting electric vehicles, and new homeowners are looking for solar. They want that in their homes. And I think that is the end for me. Yes. And so Sequoia is going to come up and she will go over more of the batteries and NEM 3.0. Sure, that's you. Okay, I'll be over here.
Oh, you got to switch us.
Oh.
While he's doing that, I might ask a couple questions of all of you. How many of you currently have solar? Nice. How many of you have battery storage? Okay. And how many of you are familiar with Simpliphi Power? So we have a little bit of work to do there. So I'll talk a little bit about our company founding because I think it's pretty impressive that we have a lithium battery storage manufacturer is based right here in Ventura County. We've been here for 12 years. So it's pretty amazing. So I'll talk a little bit about our company and we're almost there. And what battery storage can do for you, as well as NEM. There's a lot of questions around NEM 1, NEM 2, NEM 3. What does it mean? How do I add a battery? Can I? So I'll talk a little bit about that as well. I can keep talking. I'll just keep talking. So my name is Sequoya Cross. I'm the Vice President of Energy Storage for Briggs and Stratton. So I've been in this industry for just about 20 years. I started my career at a small company in Redway, California called Alternative Energy Engineering. It was founded in 1978 with a goal of bringing renewable energy and especially solar to homesteads throughout Northern California. That company grew very rapidly and was acquired by Sunrun. So a lot of people are familiar with Sunrun. From there, I decided I was going to transition away from big solar. And I went on to run an off-grid solar company in Sandpoint, Idaho for a decade. So that's where my passion for battery storage came from, was working with people who didn't have access to electricity. I've traveled throughout the world, working with people, different communities to provide energy resilience and sustainability. And so kind of bringing this full circle, now I'm at Briggs and Stratton. So Briggs and Stratton acquired Simpliphi Power about 2.5 years ago. And there we go. Now we can have slides to go with it. All right, awesome. Thank you. Thanks. So I started to tell you a little bit about our history. So OES, which was Ojai Energy Systems, was founded in Ojai, California in 2010 in a very small little building in the industrial park there. What we started to do was build smaller lithium ferrophosphate, so LFP batteries, which is one of the safest, most environmentally friendly lithium chemistries that's on the market, for residential, military, and emergency response. We were one of the first companies to get FAA clearance for batteries because of their safety. So they were able to fly on airplanes for the military, but also were able to ship batteries throughout the world. Our batteries were tested in Aberdeen Proving Grounds, had everything shot at our batteries, and they do not explode. They don't have all those catastrophic effects that you see. And that was really important to us as a company because we're putting something into homes and businesses that we want to be safe. And we wanted to think about the evolution of that battery storage, not just as an end product that ends up in a landfill, but what can we do with that product after its lifespan? And so we've always employed a cradle to cradle approach. We leverage our battery storage to be 98% recyclable. So the materials we use in our batteries, everything from the case to the components, we recycle 100% of the batteries that we get back. So we continue to expand our product line. We relaunched as Simpliphi Power in 2015. And then we started ramping up production into larger residential and large-scale commercial projects. And then we were acquired by Briggs and Stratton a few years ago. So if you don't know who Briggs and Stratton is, most people do, but they know us for lawnmowers. They don't know about the fact that we've been doing standby power for over a decade. Battery storage is a new segment for the company, and the whole purpose is electrification is big. A 115-year-old company knew this, and we're really excited to help them transition into electrification and to help them transition away from fossil fuels. So they have a very big global imprint.
or impact and imprint, I guess. And they make standby generators as well as now battery storage. I'll talk a little bit just about what impacts we're seeing. I think all of you are well aware of what is driving this change to electrification, renewable energy, but battery storage in particular. So only about 18% of homes in the US right now have storage. Only, if I remember I was just doing this, of all single family homes in the United States, 5% have solar. Of that, only 18% have storage. So when you start thinking about it, it's not a lot of storage floating out there. However, 69% of homes in the US want storage. COVID drove a lot of this. We were all stuck at home. We had power outages. We all went through PSPS at that time in California. And so people are starting to recognize the need for storing that power. We have a lot of solar in California, and now we have less incentive to, have net metering under NEM 3, but storage allows us to put that power we're generating and to leverage it for the evenings. In addition, we have infrastructure issues that are driving more power outages, climate-related events that are driving more power outages. In order to use that solar, you need to have storage to put that power if there is an outage. We're starting to see people know that their solar doesn't work when the grid goes down, but still a lot of people need to know that. Your solar will turn off unless you have battery storage. So we're seeing electrification. We heard a lot of this from SCE and other speakers. Electrification is everything. Battery storage is what's going to help us keep that even keel, but to provide utility power as well. So demand response programs, which Dave, right? Dave at SCE brought up, but demand response programs are gaining a lot of traction in the East, less so out here. But what that does, it allows you to use your battery storage to help the grid stabilize and to be able to use that power in a more effective way for the utility, and they'll incentivize you to do it. So how making sure that I'm not going over. Okay, so how do batteries increase the savings for you as a homeowner? They can help reduce peaks. So if you have peak demand or peak loads that come on, you can design a battery storage system to come on and offset that. So if you're using solar to charge up the batteries, you can actually program your inverter to come on during a certain part of the day. So that's time of use. So we often see time of use rates have now shifted more towards the evening, where your solar production is going down. Battery storage allows you to shift that power. So now you've got your solar, it's offsetting load during the day, but at the same time, it can be charging your batteries. In the evening comes in, you have peak rates, you switch over to your battery storage. So many inverters allow you to pick time windows where you can actually go in from, say, 4 in the afternoon to 9 o'clock at night, and you can use your battery storage for that purpose. You can also design and size your battery storage for that window of time if that's all you're interested in. But the great part about it is really the resiliency that you get with energy storage as well. We had a little different chart as from SCE, but this is the same effect, where this last slide here is showing what integrated solar and storage does. So you have the morning and the evening, morning and night, there is absolutely no solar production. And in the purple, I'm looking at this, the chart is wrong. So the purple is really where your solar production is. So by having energy storage during that period of time, you can charge it. Trying to read this chart. You can charge up your batteries during the day with your solar, but then you can offset your nighttime loads. That's pretty much a big thing. So the history of NEM, I'll take a little step back. So net metering 1.0, this was passed in 1995. It's been around for a really long time. And what you received was the full retail rate of your overproduction of solar. So this initially was designed to kickstart the solar energy industry. And it was designed to diversify the energy mix, to drive economic growth, and encourage private investment in renewables. A lot of us jumped on that, and it allowed this one-to-one credit. By 2013, the amount of solar that California had installed was starting to outpace some of the demand that we had. So California was starting to sell that excess generation to neighboring states until they said, I don't want any more. I don't need it. And so they started to ramp down the rebate or incentive for solar at that time, and they were increasing and adding fees for interconnection and other things. And they were putting in mandatory time of use rates. I just want to say, there's no surprise about net metering and its transition. We as industry professionals have known that this is coming for a really long time, and the whole point of net metering was to get to grid parity. We wanted to have enough solar generation that was there that we could help offset some of the load that we were seeing on the grid. So they did change NEM 3. It's now called a net billing tariff. And it took effect on April 14th. So a lot of people were, April 14th was a big day in 2023. A lot of solar installers were pulling permits like crazy, because if they could get your permit in before that time, you would still be able to have your install done through the balance of the year. But it did change the focus from payback to energy resilience as well. And part of this is we need to have energy storage. It's an important part of this equation because it allows us to stabilize the grid. It allows us to reduce some of this duck curve, is what we all talk about it as, but it really stabilizes some of these voltage fluctuations that you start getting when it's just solar, peak solar. So battery storage in demand response can also help facilitate outages in commercial solar and storage. It can also help whole communities to be more resilient. We're working on a project with PG&E, our neighbor utility up north, but we're putting in 700 battery storage systems to help with some of the fire mitigation that they've had. So I talked about battery chemistry. I just got the 5-minute mark, so I'm gonna bust right along. So lithium ferrophosphate, LFP. You'll see this a lot on battery spec sheets. It's important to understand your battery, understand what you're installing or having installed. The most common chemistry that you will see in like an EV is an emcee or some form of cobalt-based chemistry. There is transition over into lithium ferrophosphate, but the reason I bring this up is most cobalt-based chemistries require some form of cooling or a mechanism of extinguishing. So I talked about it a little bit earlier. Batteries have had everything shot at them. They don't go into thermal runaway. They don't explode or catch on fire. That's why, that's the difference. The cobalt is the chemistry within those batteries that's most volatile. And when you see some of these issues around EVs or other, scooters in New York, it's typically because of low-cost batteries that are not well manufactured and have some form of cobalt-based chemistry. Now, there are companies out there that do use cobalt-based chemistries, and they're phenomenal at what they can do. The reason why they're so great for EVs is because they can discharge really fast and provide a lot of power very quickly. So that's why they use them in power tools and EVs. Lithium ferrophosphate has very long duration. So to answer the question you had earlier, how long do these batteries last? So we can get somewhere in the range of 10, or well, we'll start at the bottom, 4,500 cycles to 10,000 cycles. So a cycle is how many times you charge and discharge a battery. The cycle life is dependent on how deeply you discharge it and how quickly you discharge it. So cycle life is sort of it's a number that we use, but it's sometimes hard to quantify. Most batteries are going to last you between 10 and 27 years. And to that effect, all of those equations, cycle life, lifespan, you're still going to have somewhere between 70 and 80% of that battery's original capacity. So it's not totally dead. It's just We as manufacturers set a limit for how much degradation will happen in a battery over its lifespan within what we call its usable life. Solar panels do the same thing. So all solar panels, they're going to guarantee you a certain amount of production with a certain amount of degradation over a period of time, and batteries are no different. And the last thing I will talk about is permitting and code. It's not a really exciting thing, but for homeowners, it's really important to understand the products you're putting in your home. And it's important to understand the safety testing, especially with batteries that they have gone through. So UL 9540 is a standard that all stationary power systems, stationary battery systems need to adhere to, that ensures the safety. It's gone through stringent fire safety testing where we actually take batteries and try to catch them on fire to see what happens. So all of this goes into a report. So if you're looking at battery storage products, it's important to make sure that it has a UL 9540 and it's gone through UL 9540A testing. Again, because of our safety, our batteries are one of the only batteries that can be installed in residences in New York City. If you've seen the news, they're very concerned about battery storage because of all the e-scooters that have had issues. And if you want to learn more about battery storage, since we only had 15 minutes, we do have one of our batteries in the booth. We'd love to show it to you and be happy to answer any additional. Oh, I still have 1 minute. Okay. Briggs and Stratton manufactures our newest battery, which is really cool. I love it. It's out in the booth. So this stack that you see here in the middle, that's 20 kilowatt hours. Why does that matter? Because most codes and standards keep you to a 20 kilowatt hour limit. But this whole battery system can be installed in about 5 minutes. So 20 kilowatt hours in 5 minutes. There's no cables, no switches. It's really fast, so we'd love to show it to you. All right, thank you.